Hey, this is Mr. Aiden. We are back in AP Calculus AB and we're with related rates. No, I'm not talking about people from West Virginia. I'm not talking about people from Kentucky, though they are related in other ways, whether they're brother and sister or husband and wife. We're talking about related rates with calculus, and this is one of my favorite topics to teach. I think it is a really neat topic. I remember when I was in college and I started doing related rates, I said, this is where calculus is making total sense to me. And my teachers were awful. And so, if my teachers were awful and it made total sense to me, you're going to be a genius here. So here we can see the radius of the circle is increasing at a rate of 3 centimeters per second. So you can see the radius is getting larger and larger and larger. So what's happening to my circle? If this radius is getting larger at a rate of 3 centimeters per second, what's happening to my circle? My circle's area is getting larger, isn't it? Okay, this is what happens in real life. Think about you drop a pebble in a crystal clear lake, and what's happening is the radius is increasing, but the area is increasing as well. Or let's say you drop some water on the ground. Same thing happens, right? And at a certain instant, time naught, the radius is equal to 8 centimeters. And so we're trying to find the rate of the change of the area. Now, let's say we wanted to just know the area when the radius is 8 centimeters. We can use area equals pi r squared, can't we? We could plug in 8 for radius, and we know the area is equal to 64 pi centimeters squared, right? At exactly 8 centimeters. But that's not what it's asking. It's asking how fast is the area changing? What's the rate of the change of the area? Not just the area. And so what do I know is it says the radius is equal to 8 centimeters. Now again, units are really important. So area at exactly time naught is equal to 64 pi centimeters squared, because that's the units of area. The radius is equal to 8 centimeters because centimeters is the units of radius in this problem. But we want to find out the change of the area with respect to time. That's what we're trying to find here. We're trying to find the rate of the change of the area. That's the derivative with respect to time. You could also call that a prime of t, because that's the change of the area. What do we know? We know the rate of the change of the radius with respect to time. How fast is the radius changing with respect to time? Is positive 3 centimeters per second. And again, units help you out. We know that this 3 centimeters per second is not the radius, because look at the units, centimeters per second. It's a rate. It's a centimeters per second. It's a radius with respect to time. And so what do we want to do is we have our formula, area equals pi r squared, which means we want to take the derivative, the d over dt, of each side here. So we have dA over dt, that's what I'm trying to find. What's the derivative of pi r squared? Well, we don't have to use the product rule here because pi is just a constant, okay? So we can take the derivative of r squared. What's the derivative of r squared? Is 2 pi r. Ooh, that looks like an equation I've done before, right? But remember, our implicit, we are going to do dr over dt. That's what we're doing, right? And so I want to find dA over dt when the radius is equal to 8. Okay, so I have 2 pi, the radius is 8. What's dr over dt? It's 3, positive 3. And so you can see 3 times 8, that's 24. 24 times 2 is 48. 48 pi. And what are the units of area with respect to time? Area is centimeters squared. Time is seconds in this case. And so that is your change of your area with respect to time is 48 pi centimeters squared per second. Okay. What I like to do is I like to make sure I get the equation, make sure I write down everything I know, and then I can solve it. Okay. And this will kind of help you out with that. You can see here we have a base of a triangle. Drop that base, you'll Okay, anyway, the base is decreasing. okay, at a rate, which means that's saying dB over dt is decreasing negative 13 meters per hour. Okay, so that is the change of the b with respect to time. And the height of the triangle is increasing. So that's dh over dt is positive 6 meters per hour. And again, you can see this is not just b and h. This is dB over dt and dh over dt. Okay, so you can see at a certain instant the base is equal to 5 meters. The height is equal to 1 meter. Okay, and it says what is the rate of the change of the area at that instant. So we're trying to find the area with respect to time. That's what we're trying to find. There's all my information there. And so you can see how, what are the units of b prime of t? B prime is a rate. So that's meters per hour, isn't it? That's the negative 13. The area, what's the units of area? This is not area prime. This is not d over dt. This is just area. Area is meters squared, isn't it? Okay. What is the height? What's the units of height? Height is meters, isn't it? I know I have 5 meters here. Okay. No, not 5 meters. That's the base. Height is 1 meter. My bad. My bad, yo. 1 meter. What's dA over dt? Well, that's the area with respect to time. The change of the area with respect to time. That's meters squared per hour, and that's what I'm trying to find. That's what I'm trying to find. So let's find this. What's my equation for the area of a triangle? Area equals 1/2 base times height. Okay. So now I'm going to take the derivative. The derivative of the area with respect to time equals, oh man, I got to use the product rule here. Which means let's take the derivative of the b first. So I have 1/2. What's the derivative of b? Is just 1. dB over dt times h plus, now I'm going to take the derivative of the height. 1/2 b times dh over dt. So you can see how I took the derivative of the base first, then I took the derivative of the height next in the product rule. Okay, so now let's plug in what I know. I have dB over dt, which is negative 13. The height is equal to 1 at this instant. 1/2 is the b is equal to 5, and dh over dt is plus 6. And when I work all of this out, I end up getting 13/2 or 8.5. And what are the units of dA over dt? The area with respect to time. Area is meters squared. With respect to time is hours there. 8.5 meters squared per hour. Now, if let's say the base was fixed, the base is not going to change. Only the height changes. Okay? Then this dB over dt would be 0. Or let's say this height changes, or this height doesn't change, but the base changes. Well, the dH over dt would be 0. So any fixed value is going to be 0 in this change, in this rate of change. But in this problem, not only is the base is getting less and less and less, the height is getting more and more and more. Okay, so you can see how we have the area is changing, and the area is positively changing. Okay, which means the area is getting larger of this triangle as it goes along. And that is related rates. Again, units help you out with related rates.